Welcome to the Englishman RV Channel. In this video I'm going to investigate the issue of rain causing E1 error codes on the Furrion tankless water heater and try to find a solution. We have experienced this issue several times, and as anyone who has experienced this will attest to, that is extremely frustrating, as you usually end up having no hot water for quite a while, a day or more. The problem appears to occur when we have experienced heavy rainfalls. After it has rained for a while and we turn on the water heater, the temperature on the interior controller raises to about 65 to 90 degrees, and then the E1 code is displayed and the flame in the heater goes out. Also, on some occasions you can hear the pilot light clicking and not igniting. When this occurs, the water heater will typically not operate for sometimes a couple of days, and every time we turn it on we get the E1 code. Magically though, after a couple of days it suddenly starts working again. The E1 code, according to the manufacturer, is caused by a low propane pressure. I did contact Furrion support several times by email and phone. As far as email was concerned, I got a response telling me someone would contact me within 24 hours, then nothing else. Nobody called me, nothing. When I called the support line, which to be perfectly honest was very frustrating, time consuming exercise, being on hold, in one case for over an hour, and when I finally got someone on the phone, they immediately disconnected after they took my name and number and never called me back. To be absolutely blunt, contacting Furrion support was completely useless and no resolution was forthcoming. To be honest, I did replace the propane regulator, as the E1 code said it was low gas pressure. I doubted that was the issue, but I thought just replacing the propane regulator would eliminate that as a potential problem. Based on my online research for a solution to this E1 error code after rain, I tried the following two suggestions. One, to blow out the tube used to sense the venting pressure, and two, using a hairdryer to blow up any water inside the heater. Neither of these two items worked for me, although some people claim to have had some success with them. In retrospect, the hairdryer may have worked, although the airflow was not high enough to be effective. The biggest success I had was to use a leaf blower and blowing it into the guts of the heater after removing the outside cover. I was very surprised how much water came out of the heater when I did this. However, this always solved the problem. My challenge was to identify what exactly causes this issue. I suspected that water was getting into the heater and infecting internal components and causing the issue with firing up the heater. Even though I suspected this, I did the following experiments at home base using a garden hose set to shower setting. I sprayed the hose up against the camper above the heater. I kept the hose on for several minutes. The issue only appeared when we had heavy rain, and I managed to simulate the issue after a significant time with spraying above the heater and having the water run into the heater. I decided to don an umbrella and do some observing during the next heavy rainfall. What I noticed was, due to the main awning ending just to the front above the water heater, when it rained a significant amount of water ran off the roof onto the awning, which I usually keep retracted during heavy rain, and a significant amount of water was pouring down the side of the camper off the retracted awning over the heater cover and into the heater, which appeared to be causing the issue. The solution I came up with was to build a small cover over the top of the heater so that water running down the side of the camper did not run into the heater. As a prototype, I created a cover over the heater using plastic from some old packaging and duct tape. The next time we had a heavy rain, it worked perfectly. The challenge now is to create something more permanent. I did purchase a mini leaf blower that I was using during the experiment of how to resolve the issue, and this worked perfectly when I had the issue. The only problem is that during a heavy rainstorm the heater stopped working, and until the rain stopped I could not blow it out. I am currently working on an aluminum permanent solution for this, and I will post a part 2 to this video once I finish the cover on how I made it. Thank you for watching this video. If you enjoyed this video, please give it a thumbs up. If not, please feel free to go ahead and give it a thumbs down. Please go ahead and subscribe to get notified of any new videos that I release.